Good day, everyone. We are from Group9, and our topic is smart home monitoring and controlling system with AI. So, what is this system? First of all, we need to know what is smart home. A smart home is a resident that interconnect all the smart home devices to the cloud. So, the monitoring and the control system can help the users to access these devices through the internet and also anytime and anywhere. These are the problems we found in the existing system and our solution to improve the problem. First of all, some of the system lack of smart home devices monitoring. It because they do not provide the insight for some particular data. For example, power consumption data. The user do not know whether the value is high or low in the power consumption data. So we provide a visualization tool for user to check the normal power consumption usage for that particular device. The second problem is some of the system lack of power consumption predictive measures. It's very important for the user who want to do the power saving. So we also provide a forecasting tool for user to predict the future power consumption along with the potential range value. So the user can make decision based on the prediction made by the AI model. The third problem is some of the system lack of alert for abnormal energy consumption. It is also very important because the user do not always pay attention to their smart devices, and it is not necessary to. So we provide a real-time anomaly detection and send the alert to the users when an anomaly in the power consumption data occurs. So our objective is we will develop a system that can interconnect the smart home devices and also integrate all the solutions here using the Amazon Web Services. And this is our architecture diagram. There are two main floors. The first one is from the user side, and the other one is from the smart home devices side. So I will introduce this side first. First of all, the user need to authenticate and authorize themselves through the Amazon Corridor. Once the user is authorized, he can visualize and focus the data using the Amazon QuickSight. The Amazon QuickSight will send the query request to the Amazon antenna, and then the antenna will query the database. After that, the antenna will send back the result to the QuickSight, so the user can check the time-specific range data. And the third service is the Amazon Lookup for Matrix. This is the anomaly detection for the power consumption data. The detector will get the data in the S3 bucket and then detect the anomaly. Once the anomaly is detected, it will send a notification to the user using the SMS services. And now, how the detector do the real-time detection? So we will use AWS Lambda to trigger the antenna to query the DynamoDB code every 1 hour. So the Amazon antenna will export the result in the S3 bucket for the detector. And the second process is from the smart home devices side. All the devices will be registered in the Amazon IoT core, and then the DynamoDB will store all the information about the smart home devices with the help of this Lambda function. So now I will demo how the Amazon Corridor works and how the authorized user is different from the unauthorized user. What is the benefit of authorized users? First of all, we will use the auth 2.0 to access to do the authorization. And we need to input some the parameters such as the authorization URL. And this parameter can be retrieved when you're creating the app client for your user pool. And now we click get new access token. We can sign out here and a new account here and also sign in. Since I have created an account here, so I can already sign in. So once I have sign in, I can get the ID token. We need the ID token to get the identity ID. So we will paste the identity token value here. Instead, and we need the identity ID. This identity ID is different. Is each user has different identity ID. So we need to send this post request, and we will get identity ID which it belong to this account. So we will use this identity ID to get the account credential. So we will use a post request to get the credential for this use account. So once we post it, we can get some important tokens such as key ID, secret key, and special token. And this key we will use in this Amazon signature. So we will paste this ID here. And please make sure that this token is and the key is not exposed to the public, or else your account may be misused. So once I have specified this parameter, so I can click send in order to see what is the content inside the HQ bucket that this user allowed to see. So this is the name of the HQ bucket and also the folder name inside the HQ bucket. So we will see how the unauthorized user can do in to the HQ bucket. Actually, he cannot do anything to the HQ bucket because he does not have the access to HQ bucket. So the user need to be authorized in order to enjoy the Amazon Web Services. And that's all from me. Thank you.
Diagram, which is the IoT core and DynamoDB. IoT core basically is managing all the IoT device and retrieve the data generated by them to our cloud. So from here we can see things or IoT device has been initialized or set up here. And by doing so, our IoT device can now communicate with our cloud. We have written a Python script to simulate the communication between the device and the cloud like this. So as you can see, after the script has been run, you can see that constantly there will be data or payload come into our topic. But data came in are all payload. Therefore, we need to use Lambda in order to process the payload so that we can update our database or DynamoDB with that, like this. This Lambda is triggered by AWS IoT. That means, means that whenever there are new data coming in, the Lambda will be automatically triggered. So when we come to the DynamoDB, you can see that all the data is beautifully in our DynamoDB and can be processed by our other services within the architecture diagram. Thank you.
Okay, now it's my turn to demo my part, which is the Amazon Athena. So Amazon Athena is to query data from the DynamoDB. To demo, I will write a simple query to ensure that the connection between DynamoDB and Athena is successfully established. So user can write any type of query in Athena to get the information from the DynamoDB. So after successfully query data using Athena from DynamoDB, we can visualize our data with Amazon QuickSight. So this data visualization is for user to able to see on how the power consumption is. So the first one is the sum of consumption by device, which is, it will show the total consumption in a month of every devices. And then for the next one is the pie chart. It shows the average power consumption, a better view of power consumption to let user to see. And then next one is the total power consumption in a day separated by different devices. User can filter out the device they want to see and the device they don't want to see. And user can also select the date that they wish to see. If user do not want to see too much of data, they can filter out the things they want. So this data visualization also provide user an insight, which it shows that the top 3 devices that use the most power consumption. The first one is the Aircon one with 138,000, Aircon 2 with 99,000, and TV 1 with 23,000. And then the last graph is to show the average consumption of the household in a day. And then it will also predict the future power consumption in advance of 30 days. So user can be have acknowledgement and use the power consumption more wisely. Yes, that's all. Thank you.
Hello, I'm Tan Jim Kit, and I'll be talking about Amazon Lookout for Metrics. Amazon Lookout for Metrics is a machine learning service by AWS for detecting anomalies within our data. So in this case, we will get the data from the S3 bucket. Once it has detected that there's an abnormal activities within our data, in this case, power consumption, it will then send a notification. It will optionally send a notification to the user through the use of Amazon Simple Notification Service, Amazon SNS. We will now hit on the demo. So this is how our detector will look like after we have activated it. If you scroll to the bottom, you will see that there's a log over here. Click on it, and you can see that the run status, the detector has successfully detected that it has gone through our data and checked whether there's an anomaly or not. So when we go to this view anomalies, you will see that you will see these things. We put this all the way to 0 so that we can see all the anomalies that it has detected. So let's see for the anomaly number 1 with the severity score of 57. You'll be able to see that the graph here is you can see that there's an abnormal consumption at the end over here. Usually we will have a consumption of, let's say, around 40. And then suddenly it's back up to 200 and finally 300. And that is why Amazon Lookout for Metrics will then show this abnormally graph. When Amazon Lookout Metrics has detected that there's an abnormal activity over here, it can send a notification to the user, as shown here. So this will tell user that there's an abnormal usage of power, and it will tell user to check out what's wrong with their power consumption. That's all from me. Thank you.